Good day. We've completed the first half of equilibrium, looking at things qualitatively for the most part without using numbers and measurement. And so first of all, we talked about gases and the properties of gases. You won't be doing Boyle's law, Charles' law, ideal gas law calculations, but you may down the road if you carry on to university. So it's nice to have seen those before you get there. When we talk about equilibrium, we're talking about reversible reactions. We're talking about reversible reactions that end up being at the same rate. So every time the forward reaction happens, the reverse reaction happens, and the macroscopic properties of the system stay the same. For equilibrium, we need a sealed or closed system. We need to get to equilibrium either by starting with the products or all the reactants or some combination. And when we're at equilibrium, there can be no change in temperature. Early on, we talked about, hey, how can you look at a reaction and tell if it's likely to go to completion, not happen, or form an equilibrium? And that involves looking at two properties. One, enthalpy, the heat of reaction, and the second being entropy, the amount of disorder. So if you have an exothermic reaction and more disorder on the product side, the reaction goes to completion. If you have an endothermic reaction and more disorder on the reactant side, that will favor the reactants or no reaction. And the other possible combinations were if you have exothermic for forward but more disorder on the reactant side, or endothermic for forward, which favors the reactants, and the products have more disorder. So those we dealt with in an earlier recap plus the PowerPoint notes. Factors affecting equilibrium. Well, temperature. Temperature will always affect equilibrium systems, cause and shift, because we're going to have endothermic or exothermic reactions. Pressure and volume affect systems of equilibria that have gases. Concentrations can affect gases, but they can also affect aqueous solutions, which is where we commonly run into that. And we have catalysts. You should have memorized Le Chatelier's principle, and you should know what a stress is and what a shift is. You should know the impact of concentration. You should know the impact of changing temperature. It's been spelled out multiple times before. If not, go back and review it. You should know the impact of pressure. We're really talking about Boyle's law here. The fact that when you increase the pressure or confine the gas more, it's going to favor the side with fewer moles of gas. And that's according to the coefficients in the balanced equation. Obviously, reversing that, decreasing the pressure, favors the side with more moles of gaseous particles according to coefficients. A catalyst gets you to equilibrium faster, but does not affect the position of equilibrium, that ratio of products to reactants. So a reminder, see the notes for more detail on each concept if you're having problems. Check answer keys, make corrections, ask questions. You've got to do it.